Hi everyone. This is our first look at alkanes. Alkanes are a class of organic compound. They're hydrocarbons, and they contain only carbon-to-carbon single bonds. We're never going to see a double bond or a triple bond associated with an alkane, exclusively single dashes, single bonds in between all of the carbons in this long chain. They have a general formula, CnH2n plus 2. That's going to be a shorthand way for us to come up with the chemical formula. Instead of just simply counting up the carbons and the hydrogens, there's a small calculation there that could really save us a lot of time. Alkanes form what we call a homologous series. There's definitely a pattern to it that we can recognize that will help us. They are classified as saturated hydrocarbons because they all have single bonds between the carbons. There's going to be many hydrogens. An alkane is going to be saturated with hydrogens. That's an important way of classifying alkanes. There's some naming rules that we need to follow. If we're presented with a structure and we need to come up with the name, there's a whole series of things to keep in mind. The first step is to just notice that we do in fact have an alkane. The other classes of compounds that we're all going to see all have a different functional group and then a different suffix at the end. Alkanes are always going to end with A-N-E in their name, ane. The second step is to count the longest chain of carbons. It's not automatically going to be the carbons across the horizontal. We're allowed to count around a corner. What's the maximum number of carbons you can get in a row? And then add a prefix, meth, eth, prop, bute, pent, hex, hept, oct, non, dec. So you might have methane, ethane, propane, octane, decane. It's going to be very common for us to see extra carbons around the longest chain. These are called alkyl groups. We usually just call them branches for short. Alkyl groups are going to have a prefix followed by YL. So these are going to be names like methyl or ethyl or propyl. If we start to see butyl, we probably want to double check our counting of the longest chain. Prop is already a little bit unusual for us as a branch length. We're going to show the location. Which part of the longest chain is the branch attached to? The location. For that, we're going to use a digit, an actual number, 2, 3, 4. Okay. This digit, we need it to be as small as possible. We're going to find ourselves counting in opposite directions to keep that number low. A surprising thing is, if there's only one possible location for one of these alkyl groups, then we're not going to use a digit. It simplifies it if we can't use a digit. If we have the same kind of branch, then we're going to add a di at the front. Or if there's 3, a tri. If there's 4, a tetra. So if we had 2 different methyls, we would call that dimethyl. If we had 2 different 2-carbon branches, we would say diethyl. If we had 3 methyls, then we would say trimethyl. Different branches, however, are going to be named alphabetically. If we have an ethyl and a methyl, well, E comes before M alphabetically. And if we did add a di or a tri into our name, that does not factor into our alphabetization. This means that ethyl comes even before dimethyl. The D of the di does not factor in. We're focused on the M of the methyl. Our first class of compound that we've encountered are alkanes. They're pretty simple hydrocarbons. They all have single bonds between the carbons, and they are linear. We might find ourselves counting around a corner to come up with the longest chain, but that's still all in a line. There's a bunch of rules to keep track of as we're going to come up with some names in the next video, and I hope that helps.